So, good afternoon, everyone, and welcome to this lecture on circular motion. We are trying to wind up circular motion, and let's see how far we can go in this class. I'm thinking of finishing this circular motion in this class. Let's see how we go. What we have done in the previous classes, we have seen the equation of motion for circular motion. Yes or no? That is what we saw in the last class. How the equation of motion are in circular motion and how they were in linear motion. And we had seen that they are all same. Yes or no? Everything is absolutely similar. So what we will do is write everything together and we can put them in one column and then we can see how these things are in angular motion or circular motion or rotational motion and how these things look like in your linear motion. So I can write the term, the name of the term, then we will see how it looks in linear motion and how it looks in angular motion or rotational motion or circular motion. Okay. The first term that we saw was position. In linear motion, the position was given by r vector, position vector. In angular motion, it was given by angle theta. I hope you all understand this, yes or no? So you just keep on writing. The next term that we saw was displacement. Here it was written as displacement vector. Here it was written as change in angular position over delta theta. The third term was average velocity or average angular velocity. Here it was written as v vector and that was equal to delta r vector by delta t. Here it is written as omega. It is not a vector. Average angular velocity is delta theta total displacement divided by total time. I hope everyone is understanding these terms, yes or no? Then the fourth one was instantaneous velocity or instantaneous angular velocity. We wrote it as v vector here. It was dr vector by dt. Here also it is a vector. It is d theta vector by dt. Then we had seen a motion which was motion with uniform velocity. Uniform motion velocity is constant. Here omega is constant. We call it uniform circular motion. Do we understand this? Yes or no? There we had seen a frequency. We had seen the value of omega is 2 pi by t or it is equal to 2 pi into f. We have seen this motion. Then we had seen average acceleration here. Here it was a vector. Total change in velocity divided by total time, or I can write it as v minus u divided by t. Here we write it as angular acceleration alpha, total change in angular velocity divided by total time, omega 2 minus omega 1 divided by t. I hope all of us are understanding this, yes or no? Then we had the term on instantaneous acceleration. Here it was written as A vector dv vector by dt. Here it was written as, bracket, sorry, alpha vector. I've changed this, huh? Just remember this. This is a bracket here. Alpha vector d omega vector by dt. Here we have talked about motion with constant acceleration. A is constant. Acceleration instantaneous value becomes equal to average value. Here alpha will be constant. Instantaneous alpha will be equal to average alpha. Do we understand all these terms? Okay. I hope you have written it till here, everyone. Then we had also seen the equations of motion. We will just write it again. Equations of motion we had seen. I'll write it again. The first equation was v is equal to u plus at. In vector form, it was written like this. In scalar form, it was written as v is equal to u plus at with proper sign. I will not write them in the vector form. Let us write in the normal form. So I write it as v is equal to u plus at. Here we had used the sign convention. The sign convention was pretty simple. This side was positive, left side was negative, up was positive, and down was negative. Yes or no? We remember this? You can write the same equation here. Omega 2 will be equal to omega 1 plus alpha t. Here the sign convention is this is positive and clockwise is negative. Second equation was displacement. Here it was third equation, v square is equal to u square plus 2a delta r. Here omega 2 square is omega 1 square plus 2 times alpha into delta theta. Fourth equation was displacement in the nth second. Here it was angular displacement in the nth second. I'll give you 2 minutes to note everything down, then we can move on to some questions.
Hello, sir.
Yes, beta.
Sir, can you show previous one, sir? Sir. Yes, sir. Okay, sir.
Everyone has noted this down?
Yes, sir.
Okay, let us see if you can solve this question.
Sir, can you show next page?
Still not done? Okay, note it down. You should know all these things. Still, if you have to look at the whiteboard, that means you don't remember them. If you don't remember them, that is not a good sign. We have done these three things at least 3 or 4 times now. So still have to look at the board. That means you don't remember them. That is a bad sign. That is a bad sign. Shall we move on?
Yes, sir.
Sir.
Okay, so this is the first question on this category. A particle is moving with a constant speed in a circular path. Find the ratio of average velocity to instantaneous. No, you cannot do it right now. I have not told you something, so we'll leave it here. We'll leave it here. Don't write this question. We will do it afterwards. We will do it afterwards. Let's take this out. This average velocity, not average angular velocity. So we'll do this one first. We'll do that one, but after some time when I tell you something more about it. Okay, we'll do this one. A fan is rotating with a angular velocity of 100 revolutions per second. Then it is switched off. It takes 5 minutes to stop. Find the total number of revolutions made before it stops, assuming uniform retardation. They're asking you the total number of revolutions, remember. Find the value of angular retardation, assuming it to be uniform. Find the average angular velocity. Let's see if you can give me this one. Give you 2 minutes to solve this. I hope I have told you the relation between revolutions per minute, revolutions per second. So let's see if you can use it. Anyone got any answer? Shall I do it? Do you need more time? Okay. Anyone with any answer? Shall I do it? Okay. So first of all, this velocity that is given is omega 1. Omega 1 is 100 revolutions per second. It is switched off, so it stops. So omega 2 is 0. Time is 5 minutes, so you can call it 300 seconds. Find the total number of revolutions that are made. So you can use different equations. Which different equations you can use? You know omega 1, you know omega 2, you know time. So first of all, you can calculate the value of alpha. Yes or no? The angular acceleration alpha. How will you get the value of alpha? You can use equation number 1. Omega 2 is equal to omega 1 plus alpha t. Yes or no? Everything is known. You can calculate the value of alpha. Alpha will come negative because it is in the opposite direction. What is the value of alpha you are getting? It will be 100 divided by, so it will be 1 by 3 with a negative sign, revolutions per second square. Yes or no? Now, if you want to convert it into radians per second square, remember second are same, so you can convert it into radians per second square by multiplying it by 2 pi, because one revolution is 2 pi angle. So you can write it like this also. Alpha will be minus 2 pi by 3 radians per second square. Do we understand this? That is alpha. Once you get the value of alpha, you can find out the rest of the things. How can you find out the rest of the things? If you have to now find out the total number of revolutions, how many revolutions it has made, how can you find out the total number of revolutions? You can apply the formula. Angular displacement is omega 1 into t plus half alpha t square. Now, if you use everything in revolutions, you will get the answer in revolution. If you use everything in radians, you will get the answer in angle. They've asked how many revolutions are done. Let us use everything in revolution. So I can put delta theta as omega 1 is 100 revolution per second multiplied by 300 plus half alpha into minus 1 by 3 into 300 square. Do we understand this? Yes or no? You can calculate this, how much you are getting. How much you are getting? The answer that I have is 15,000 revolution. It is correct? Yes or no? Is this the correct answer? Yes or no? No one got this? Okay. Then you have to find out lastly the average angular velocity. How do you find the average angular velocity? The average angular velocity is total angular displacement divided by total time. You can just put the values. So omega average will be total angular displacement is 15,000 divided by total time is 300, and you will get your answer in revolutions per second, 50 revolutions per second. If you want to find the answer in radians per second, multiply it by 2 pi, because seconds and seconds are same. So it will become 100 pi rads per sec square. Do we understand this? Anyone got this? Yes or no? Well, this is the way we have used all the three equations and find out the answer in one possible way. But as I keep on telling you, this is not the only way this could have been done. You could have done it in a different way also. Everyone got this one? Yes or no? Do you want to note it down? Shall I wait for you to note it down? Okay, note it down. Let me know once you are done. Boys, are you done? Chalo. Now, this was one way of doing it. Obviously, there is nothing wrong with this. I could have done probably in a different way, which would have given me the answer without so much of calculations. Now, remember, I told you a formula. I gave you a formula in your 1D motion where I said for constant acceleration, I can say that your average velocity will be v plus u divided by 2. Do we remember this formula? No. Then similarly, I can say for constant angular acceleration, I can write average angular velocity will be omega 1 plus omega 2 by 2. Yes or no? Now, if you could have used this formula, you could have got the same answers very, very, very quickly. How could you have got the answers very, very quickly? The first thing that you would have calculated is question number 3. Question number 3 was average angular velocity. You could have easily got the average angular velocity. Very simple. You knew the original velocity omega 1 was 100 and the final velocity was 0. So average omega was 0 plus 100 divided by 2, and straight away you would get the answer as 50 revs per sec. See, it was so simple. As soon as you got the value of average angular velocity, then you could have used this formula. Average angular velocity is total displacement divided by total time. Total angular displacement divided by total time. From this formula, you could have straight away got the total angular displacement is average omega multiplied by t. So average omega is 50 multiplied by time is 300, and you could have got the answer 15,000 revs very, very quickly. To get the value of alpha, you'll have to use the previous method. You know omega 2, you know omega 1, you know time. You can calculate alpha from there. But to calculate the other two quantities, these equations were more smarter because you could calculate them quicker, and that is what that matters, that you can get the answers quickly. Do you understand this? Yes or no? Okay. Having said this, we have seen the relation between angular and linear quantities. I'll give you 2 minutes to go through them. If you have any doubts, ask, else we will move ahead and see what is the relation between linear and angular quantities. So that is the next heading. Before going on to the next heading, I'll give you 2 minutes. Go through what we have done. If you have any problems, ask. 2 minutes you have. Shall we move ahead? Okay. So now the next heading is relation between linear and angular quantities. And the first relation that we are going to see is between distance and the angular displacement. So what I have done is I have drawn a circle, and this is my center O. This is my radius R. Now, a particle moving on a circular track, let us say at some time he is at point A, at some other point time he is at point B. Now he has moved from point A to point B. There has been some angular displacement. Yes or no? This delta theta is the angular displacement. Do we understand this? But at the same time, if you look, he has traveled some path. From A to B, he has traveled some path. The length of this path is known as what? If I calculate the length of this path, that will give me what?
Distance, sir.
The length of this path will give me distance. Now this path is actually arc of a circle. Yes? Any doubt? This A to B is a part of a circle, is the length of the arc. We can relate length of the arc with the angle and radius. Anyone knows the relation between length of the arc, radius and angle? Length of the arc L will be the angle, which is delta theta, multiplied by R. This becomes the relation between length or distance and angular displacement. This L is your linear distance or distance traveled by the body. This, my dear friends, is the angular displacement. So what we have done is, by finding out how much angle it has turned, you can find out how much distance it has traveled. Do you understand this? Yes or no? I'll give you 2 minutes to note this down.
Done, sir.
Boys, have you done this?
Yes, sir.
Well, then comes the next relation, and this next relation is between linear and angular velocities. Again, we have the same thing. We have a circle with center O, radius R. A particle is moving on this circular track A. It has some velocity. This is the same velocity that we use, that we know. This is the velocity v, but we also know that this is moving on a circle, so it has an angular velocity. Its angular velocity would be like this. Now this velocity here, it is your original velocity of the particle, that what we were understanding from the previous classes. But here, since you can see that this velocity is along the tangential direction, there are two directions that you can draw in a circle. One is the radial direction, which is towards the center, and one which is perpendicular to it, which is known as the tangential. Do we understand this? Since this velocity, if it is moving in a circular track, its velocity is always tangential to the circular track, we can call it Vt. Now, there is definitely a relation between Vt and omega, and it is derived from the first relation that we had seen. Both of these are vector quantities, so there exists a vector relation. Vt vector is omega cross with r. Have you studied cross product of vectors? Yes or no? Yes. It is the cross product of omega with r. It is the cross product of omega with r. Vt is your actual vector, the vector that we have learned. This omega is a different type of a vector. Whenever we talk about these angular quantities, and whenever we talk about vector angular quantities, these vectors are a different type of vectors which are known as axial vectors. What do you mean by axial vectors? Their direction is not given by this or this. The direction is given by the axis. And we will study about these axial vectors in the chapter on rotation. Let us not get more into that axial vectors. We'll just take it as omega cross r. You know how to find the cross product. You can find out the cross product. Yes or no? This is the vector relation, but we can also find a scalar relation which relates the magnitude of the two velocities. What is the scalar relation between these two? The scalar relation is simply v tangential is omega multiplied by r. And as you can see, it looks exactly as what we had seen here. See, I'm showing you both of the relations there. L on the left hand side was the linear quantity. Vt on the left hand side is the linear quantity. We call it tangential velocity because it is tangential. Delta theta was angular displacement. Here this angular displacement has been replaced by omega, angular velocity. R was the radius. There also R is the radius. So both the quantities look similar. Yes or no? Okay. This was the relation between linear and angular velocity. I'll give you 2 minutes to note this down. Have you
Completed,
all
sir.
noted it down?
Completed, sir.
Then we come to this next relation. Relation between linear and angular acceleration. We again go back to that circular path. O is the center, R is the radius. Now I have a particle A. Now, this particle A may have some tangential velocity like this. It can also have something known as tangential acceleration, AT. Now, if this tangential acceleration is in the same direction as tangential velocity, its velocity will increase. If this tangential acceleration is in the opposite direction, its velocity will decrease. Do we remember this tangential acceleration I told you some time before? Do you remember it? If you remember it, this is the tangential acceleration that we're talking about. Now, this tangential acceleration comes because of angular acceleration. So, angular acceleration of this body is alpha like this, and that is why this tangential acceleration is like this. Its angular velocity omega is like this, and therefore its tangential velocity is like this. There exists a relation between alpha and AT, and that relation is similar to what the relation between omega and VT was. Can you tell me what is the relation between AT and alpha? Remember, AT and alpha both are vector quantities. The relation between AT and alpha is similar, same as the relation between omega and VT. Can you tell me the relation? What is the relation between AT and VT? No one knows it? I'm waiting. No one knows it? Okay. So the relation will be like this. AT vector will be equal to alpha cross R. That is the relation between tangential acceleration and angular acceleration. If I talk about the scalar relation, I can write it like this. AT is alpha into R. That is the relation that I was looking for. And if you understand, this relation is exactly similar to what relation we had between Vt and omega r. It's very simple. If you understand any one of these relations, the other two are exactly similar to the one that we have understood. Length of the arc is delta theta, angular displacement into r, tangential velocity is omega multiplied by r, and tangential acceleration is alpha multiplied by r. Now, if you remember, what is the job of this tangential acceleration? Anyone remembers what does tangential acceleration do? What does tangential acceleration do? AT. What is the job of tangential acceleration? Tangential acceleration changes the magnitude of velocity. And let me write it as Vt so that you understand. AT changes the magnitude of Vt. If AT is in same direction as Vt, then Vt ka magnitude will increase. It will increase your speed. Vt ka magnitude means the magnitude of your speed will increase. What do you mean by this? If your tangential velocity is like this, and your tangential acceleration is also like this, tangential velocity will increase. Same direction, it will increase the magnitude. What happens when it is in the opposite direction? If AT is in the opposite direction, as VT, then the magnitude of VT will decrease or your speed will decrease. If your VT is like this and your AT is like this, it will decrease your speed. If your tangential acceleration is 0, that will imply your alpha into r is 0. That implies your omega will remain constant. That implies your tangential velocity ka magnitude will remain constant. This type of motion is known as where there is no tangential acceleration, where there is no angular acceleration. What is this type of motion known as, beta? Where omega remains constant, the speed of the particle remains constant, it moves in a circle. What is this motion known as? No one knows it?
Uniform angular velocity, sir.
This motion is known as uniform circular motion. We have done it so many times. If you don't remember the names, only God will help you. And I will pray that God helps you. Uniform circular motion. Omega is constant. This type of motion is known as uniform circular motion. I had discussed it just today when I was giving you all those formulae. I had told you there also it is uniform circular motion. No one remembers it. Well, told you uniform circular motion, UCM. Everyone has written. Even my 7-year-old kid can write from a whiteboard. There is no difference between you and him. If I would have told him 3 times that alpha is 0, that means omega is constant, and that means UCM, he will tell me after 1 year also that, sir, Papa, this is UCM. You are worse than him. And he is only in 2nd standard. Yesterday also I told you about uniform circular motion. No one remembers it. Well, if you can't remember one thing that I've told you 2 days ago, or maybe to 20 minutes before, in the class, there is no need of studying, beta. Because your exam is going to happen after 2 years. You will remember nothing in that exam. Why to give? Why to waste time? Waste time and money. Useless. You should not waste your time and money. Try to remember things. And the problem with you guys is you know only one thing. And that thing is very simple. Whatever is there on the board, note it down. Because we don't have brains to understand it, we'll note it down. So note it down. This is UCM. Tangential acceleration. The job of tangential acceleration is to change the speed of the particle. But even in UCM, something is changing. Even though the speed is not changing, something is changing. What is that something that is changing? Even though the speed is constant, something is changing. What is changing? Say,
Direction, sir.
direction of what? What is changing? What is changing? Speed is not changing. And what is changing? Boys, what is changing? Is there anything that is changing or not? Speed is not changing. Something is still changing. What is that changing thing? What? No one knows that. The speed of velocity, the magnitude of velocity is not changing, but the direction of velocity, the direction of motion, direction of velocity is continuously changing. That means velocity is changing. So there must be something that changes the direction of velocity. What is that thing known as that changes the direction of velocity? What is that thing known as that changes the direction of velocity? Yes? Anyone knows it? Obviously, I have told you this. Way back when I was talking about acceleration, and everyone has forgotten what is acceleration. So why will they remember this? Something that changes the direction of velocity is known as centripetal or normal or radial acceleration, which changes the direction of velocity. Centripetal or normal or radial acceleration that changes the direction of velocity, my dear friends. You don't remember it? Well, still I have to tell you. And I hope better sense will prevail. Again, I come back to my diagram. I have my center O and radius R. Still, this gentleman is rotating, moving in circular path, Vt, tangential velocity. It may or may not have tangential acceleration, but it always has one acceleration which is pointed which direction? Which is pointed towards the center. Like this. It is pointed towards the center. And therefore, this central is known as, this acceleration is known as ACP, centripetal, or AR, radial. It is along the direction of the radius. Or AN, normal, because it is normal to the velocity. Three names, I told you all these three names. A normal. And the vector equation for this A normal is omega cross Vt. Omega of this gentleman would be like this. If I take the cross product of these two, I will end up with the normal acceleration. This is the vector equation of normal or centripetal or radial acceleration that exists. A scalar equation also, you can write it as omega v into t, omega vt. But you know that's vt is omega into r, so you can write it as omega square r or you can also write it as Vt square by r. Normally in the question that you will find, they will not give V as Vt, they will just say velocity. Remember, whenever they say velocity, they mean tangential velocity. Tangential velocity. What is the job of this normal acceleration? It changes the direction of velocity. It changes the direction of velocity. Cannot change anything else. It changes the direction of velocity. What changes the magnitude of velocity? It is centripetal acceleration that changes the it is tangential acceleration that changes the magnitude of velocity. Therefore, tangential acceleration is sometimes also called as rate of change of what? Speed. It changes only the speed. So you can call it very vaguely as the rate of change of speed. So does that mean we can call radial acceleration as the rate of change of direction? No, we don't call radial acceleration as rate of change of direction. What all things you have to remember about this? An is always perpendicular to Vt. It is always directed towards the center. This is, and it changes the direction of velocity. Oops, wrong color. I hate wrong colors. Changes the direction of velocity. Now we know tangential acceleration. Now we know normal or centripetal acceleration. What about we also know angular acceleration. What about the acceleration that we had heard about? Where is that acceleration gone? That acceleration is still there. This A vector, this is the rate of change of velocity. Velocity may change in magnitude. Who is going to change it in magnitude? This tangential gentleman changing the magnitude. It changes the magnitude. You can call it rate of change of speed. So you can write it like this: magnitude of tangential velocity plus an. It changes the direction. They both come together. They change the tangential velocity. Both are perpendicular to each other. At is perpendicular to an. An is perpendicular to Vt. And if someone asks me, what is the magnitude of acceleration, my dear friends? So magnitude of acceleration, dung, 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 is equal to under root of At square ka magnitude plus An square ka magnitude. I hope you will now remember it, because if you don't remember it now, well, it is not going to come back. This is the last time that we are hearing these terms. To understand them, from now onwards, whenever we hear these terms, we must know what they mean. If we don't remember them, well, no problem. We will lose some marks in IIT. What happens? We lose it to lose it. We are there to lose. We are not here to win. Right? So we lose it. No problem. But if you don't want to lose it, remember them. Velocity can be changed in magnitude, can be changed in direction, can be changed in both. Tangential acceleration changes the magnitude. Normal or radial acceleration changes the direction. They both come together and change the velocity. That's it from today's class. In the next class, we will try to wind up this chapter. I hope you have understood this. I've already sent you the sheets. Best of luck. And I hope that you will remember them. Please practice. That is the only thing that you can do. Bye-bye. Take care. God bless you all. Please study. We are putting in a lot of work. Please don't let it go in waste. Bye-bye.
Thank you, sir.